Modeling, as you all know, that in any field, not only in the earth science, is very important because, especially in the oceanic science, we cannot make the observations in the entire ocean. That is where the modeling and the remote sensing always comes into the picture to see that on the basin scale how things are going on. And as Professor Vijay Raghavan was mentioning about the climate change, if the climate change occurs, how the biology is going to respond, how the human interferences are changing the ocean chemistry. So these are all important in the Anthropocene. While the modeling is important, if there is a bad projections if you have done because of the uh, non-understanding of the certain processes, we may end up with a different interpretation that will have an impact on even on the nationwide. For example, I'm taking an example of the Bay of Bengal because it has a more human dimension to that. Because of Bay of Bengal's coastal region, there are 400 million people are living close to the coast. So their impact is expected to be on the bay. If you plot the population with reference to the longitude and the latitude, this is the zone you have the high amount of the population living there. The other important one is that the fertilizer point of view, India is actually the second largest country in the world after China utilized on the consumption of the fertilizers. The third one is also that in terms of the atmospheric pollution, even India is also is having the highest atmospheric pollutant, and afterwards it comes to the even China is also having the similarly high. So based on these three, high human population around the Bay of Bengal and high fertilizer consumption and the atmospheric pollutants, several hypotheses have been made which are unproved, but what they say is that mainly the India, which is releasing all these fertilizer pollutant into the Bay of Bengal, and all the pollutants are going into the system, and it's changing the biodiversity even beyond the national boundaries. Beyond national boundaries and beyond the economical exclusive zone. These hypotheses, more important one has come from the United Nations supported Bay of Bengal large marine ecosystem project. What they said is that there is a severe depletion in the fishery resources in the Bay of Bengal, mainly coming from the human induced pollutants into this region. Make a note here that there were no evidences to see that there is human related pollutants were there in the international waters. More recently, it was published in Nature where they say that Bay of Bengal may become a dead zone very soon. It is already at the tipping point because the pollutant coming from the land and increasing the production, and therefore the oxygen depletion in the subsurface waters and the migration of the fishery resources are possible. Looking at these two reports, and also there are other reports, all I'm not talking about, United Nations has released a issue on in 12th July 2017 stating that the fertilizer, the pollutant released from the countries surrounded by the Bay of Bengal, and there is a significant impact on the biology in this region. So we need to fix these issues under the biodiversity beyond the national jurisdiction. So there's a committee has been formed to see that whether really this kind of impacts are there in the bay. Now, since we don't have the much information on really whether our rivers are sending this kind of a pollutant into the system, we made some kind of a survey in all our rivers along the Indian coast, mainly the major and minor medium rivers. Then we found that, so these are the magnitudes of the nitrogen and the phosphate and the silicate is being fluxed into the coastal waters. About 96% of the riverine nutrients have been actually trapped within the rivers or are removed in the estuaries. Only the 4 to 5% has been fluxed into the coast, and we don't have any signals, mainly in the east coast, that is where the major rivers are debouching. No eutrophication signals have been found along the coast. Now, we also gone little further ahead using the isotopic signatures. We found that whatever the pollutants are coming from the rivers, they are actually spreading up to 15 to 20 kilometers from the coast, not beyond that. Beyond that, actually, what the signals you have typically a pristine open ocean signals. Even if you look at the remote sensing primary production that is coming from the chlorophyll, you see that very high chlorophyll in the coast, which is obviously been seen, but not much actually the production you will see in the open ocean regions, which is contrasting to that of the hypothesis that a lot of anthropogenic nutrients are going into the open ocean and we should have the blooms even in the open ocean regions. But if you look at the models which have been done, this is an example of the one model I'm showing here. The many models, what they show is that in the bay, a lot of nutrients are coming from the rivers. Despite their no data from mainly from the Ganges and Brahmaputra, those are the main rivers which are actually bringing the nutrients to the system. They show that in the future, that the nutrients are expected to be increased in the bay and it will decrease in the Arabian Sea because Indian Ocean is rapidly warming, that leads to decrease of the vertical mixing. And they also show that in the Arabian Sea region, the production is expected to be decreased in the future, and whereas in the Bay of Bengal, the diversity is expected to be changed. On the other hand, if you look at the remote sensing point of view, it's a contrasting to that. It shows that in the Indian Ocean, production is expected to be changed, increased. It is obviously this is the contrasting difference between the models and the observations. What the main reason for that is that in the ocean, especially northern Indian Ocean, not only here, everywhere you will see that there is some kind of eddies are being formed. These eddies, some eddies which are the cyclonic way, they rotate, other one is rotated in the anticyclonic way. The cyclonic eddies actually pump naturally the nutrients into the surface, where the anticyclonic eddies actually pull down. We have the less nutrients in this region. They change significant amount of the production. But global models cannot able to reproduce this kind of a features, which are very important. Some of the regional models try to simulate this kind of a features in the regional scale. The second important one is that we always say that inorganic nutrients, mainly the nitrates, ammonium or phosphate, these are the ones which are very important for the primary production. But there are organic nutrients. There are only specific groups of the plankton can able to utilize the organic nutrients. In the absence of the inorganic nutrients, the organic nutrients can able to pick up, they can do significant amount of the production. But no models can able to reproduce the organic nutrients very well. They have in their system, but if you look at them, the variability is very weak. They could not able to constrain very well of the organic nutrient distribution and their inclusion into the biology. The other one is that for the decades long, we are measuring the primary production or the photosynthesis in the marine environment. We always measure as a particulate organic carbon. But there are the significant amount of the dissolved organic carbon also produces. So now about the 99% of the primary productivity measurements are only the particulate organic matter point of view. So about the 60%, especially in the Bay of Bengal, it produced in the form of the dissolved organic carbon, which is unaccounted, and no models actually simulating this kind of a dissolved organic productions. The other one is more important for the bay. Normally Bay of Bengal we call it as a sea, but actually Bay of Bengal we can call it as an estuary also. Because of a lot of the fresh water is being coming here, that is also bringing the lot of suspended matter. This suspended matter can able to remove the phosphate. Now if you look at even the fertilizers we are actually discharging into the ocean, so that is in form of the nitrogen or the phosphorus. The phosphate can be removed in association with the suspended matter. So only nitrogen cannot make the production without phosphate. When we made a measurements on the phosphate absorbed on the suspended matter, that comes up to the 30 to 50% in the different time scale periods, like the monsoon versus the non-monsoon. But the traditional way, we don't actually separate them. We always think that even this fraction is also available for the biology to utilize it. So therefore, there is naturally the removal of this part of the fertilizers from the water column. So the impact has been minimized in the natural. way. The other one is that the atmospheric pollution, which is quite high. There are several scientists actually, when Dr. Sarin is here, they made the what kind of how much of the nutrients are coming from the atmospheric deposition, like nitrogen and the phosphorus, iron, and so on. And they also shows that about 13% of the production can actually support from the atmospheric deposition. And even in the coastal regions, it may be much more because the coarser fraction can be deposited close to the coast. Based on this kind of observations, the modeling part has been done mainly by the Jews, where they said that the atmospheric deposition is expected to be increased tremendously in the over the Indian Ocean, northern Indian Ocean, in the future by 2030, and by 10 to 100% is expected to be increased, using the business as usual kind of scenario. But if you look at aerosol optical depth, which is given by the satellites, that shows that between 1990 to 2009, 0.07 per decade of the aerosol optical depth is being increased, and then reported to be the highest in the world that has been seen over the Bay of Bengal, followed by the South China Sea. But if we increase that to the 2019, that actually was decreased in the recent years. This is over the Bay of Bengal, not actually on the land. So for the last decade, this was not actually increasing at the same rate, but actually models are projecting in the same way. If the business as usual scenario, if this increases, it is much more than what the reality is showing in the data. If you look at the air-sea fluxes, which is another important one for the climate change, Bay of Bengal always been seen as a sink for atmospheric CO2, and models project that it keep on sinks even in the future also. But atmospheric deposition, they are actually bringing some acidic aerosols like sulfates or the nitrates, which can actually form the acids. So we've seen that in 1991 per se, in this region was a sink in the Bay of Bengal Northwest, but in the 2011, this became a source. So the atmospheric deposition is also changing the acidity or acidification of the coastal waters, and therefore these changes were not actually reflecting in the models. The main reason is that oceanic models are mainly working on the ocean. There is a coupling to the atmosphere mainly for the physics, but not for the chemistry. So atmospheric chemistry models have never been coupled to the ocean chemistry models. That was the reason we are missing this kind of a links or the boundaries where this kind of chemicals can be exchanged. The last point I was going to tell about the dead zones formation, which has been interpreted by the German scientists in the Nature. What they said that they using the new sensors, they found that certain zones we have very low oxygen in the nanomolar scale. In the small increase of the nutrients can able to make these zones as the dead zones in the very near future. These kind of statements are based only on the single observations, and the consistency, whether it is the permanent future or it actually happens for a certain times, has never been checked. Then what we did was that in the same zone where they made the measurements, we collected some data already been available or even from the Argo floats, which actually Inquis is being deploying from Indian side. What it has been seen is that if there is a cyclonic eddy, oxygen will be very low because the nutrients are injected to the surface and the production increases, and therefore the oxygen decreases in the down. The anticyclonic eddies, because the waters are sinking, they are actually injecting the oxygen into the deeper waters. This kind of difference you will see that. In the same zone where they reported expected to be the dead zone, but from the 1980s to present, this kind of variability you have. At the same time, Argo-based float, they also shown that there is a large variability of the oxygen within the system because of the movement of the oxygen cyclonic and anticyclonic eddies. But the models, what they show is that there is no variability of the oxygen in the oxygen minimum zone in the northern Indian Ocean. Because of these smaller features like eddies or the solubility fraction and the upwelling kind of features were not well reproduced in the global models, they show that oxygen is not being changed in this kind of regions. Not only in these models, but also in the IPCC models, which were actually asked to check in the Indian Ocean region whether how good they are actually projecting. What we have seen actually in 2013, this analysis was done by all the IPCC models which are giving inputs for the global change. These are the observations, what it is showing about the sink, the north of 20 degrees south in the Indian Ocean, but these are the models are predicting. Models are predicting too much CO2 going inside, but the observations are showing almost 50% is wrong from the what models are showing. Mainly what we have seen is that not even the seasonality they could able to reproduce in the northern Indian Ocean, because it's a monsoon system, different mixing patterns you have, and these are not well reproduced in these models because they are not taken into the consideration. The main problem comes from the models is that you have a typical NP-DZ model, like a nutrients, phytoplankton, zooplankton, and the detritus. We have a different components into that, and then we have interactions among them. But many of these time scales were taken from the somewhere else, like in the Pacific or the Atlantic. They were not really derived in the Indian Ocean. That's why we are not able to simulate the well of this real processes. And there are certain things like, as I mentioned, that organic nutrients or the many of the constraints were not well done in the Indian Ocean models. That was the reason actually we were getting the wrong signals. The more importantly, the climatology of the data is very important for the model to run. But the climatology of the Indian Ocean is quite weak for the chemistry point of view. The very little data is available. The extrapolation of this data is becoming a base for the model to run in this region. That will reflect here is that you have a nitrate, nitrocline is somewhere at the 80 meters, but the model shows the nitrocline at the 40 meters. That means the model, if there is a mixing is taking place below the 40, it gives the nutrients. But actually in the reality, unless it goes to the 80 meters, you will not get the nutrients. So in the summary, that the present biogeochemical models are not really projecting the true values, and because the lack of either the good climatological data or the weak parameterization of the processes. So we must take the care while we are interpreting this kind of the data or the projecting for the future variability. And the new information on the processes must be incorporated to have the better prediction and to see that how biology is expected to modify due to the climate change. Thank you so much.